supplement with a separate sheet of paper for yourselves. Okay? Because, yeah, well, actually, have your textbooks out because it looks like we go back to page 820 coming up here. Okay? But yeah, so we'll have a little bit of notes going on here for you outside of your textbook. Okay? So yesterday we were evaluating logs and we were estimating what the value of that log was. And the big example that we started with was log base 3 of 33. And we estimated that to be somewhere between 3 and 4, and we actually said that we estimated that it was closer to 3 than 4, so we gave in that 3.1, 3.2, 3.3 range as an estimate of that. Now, estimates are great, okay? They kind of put us where we should be, okay? But in math, 2 plus 2 is 4, okay? It's not about 3.9, you know what I mean? It's 4. And so we need to come up with a way that we can get what the exact value of these logarithms are. Okay? And how we do that is something called the change of base formula. And the change of base formula is right here. Okay? So if I need to figure out what log base b of c is, and I can't, and it's not, c is not a power of b, you know what I mean? If it was like log base 2 of 8, 8 is a power of 2. So that one's going to be 3. We've done those already. Okay? You know what I mean? Okay? What I mean here is, what if we had log base 3 of 33? What power do I put on 3 to get 33? Okay? Now, calculators are limited in what they can do. Okay? Most of you, I see on your desks, have the scientific calculators. Okay? And on the scientific calculators, you have two keys. You have a log key and you have a natural log key. Okay? And ln. By the way, ln, it's ln because it's logarithm natural. Okay? And so that's why it's ln. The guy that came up with it was a French dude. Okay? Now, what's up?
Does that say log base b?
Yes.
Like,
Or this is log base A right
okay,
here.
what about the
Yeah, what is the problem?
the equal? Like where it says logs.
This right here is
Yeah.
log base B of C.
Okay.
Yeah, we'll get to it yet. I haven't gotten that for you. I'm still explaining.
Well, no, I just wanted
Yeah.
to copy
Yeah,
it.
no, I got you. Okay? So on your calculators, the log key is for common logs. It's log base 10. Okay? And the natural log is log base E. Okay? So you're limited on your calculators. You can only find logs, so common logs, log base 10, and natural logs. But so how are we going to figure out log base 3 of 33? Okay? Well, that's where change of base comes in. So if I have log base B of C, what that says is I can take, and I don't even want you to copy that one down. Let's go down here. We'll go down here, and we'll say, instead of log base B of C is going to be either you're going to take the log of C and divide it by the log of B, use common logs on it, or you're going to take the natural log of C and divide that by the natural log of B. Okay? And then you can use your calculator to figure that out. Okay? So, if we are finding the log base 3 of 33, I'm either going to make that be the log of 33 divided by the log of 3, and we'll talk about typing it in the calculator here in a minute, or I'm going to make that be the natural log of 33 divided by the natural log of 3. Now, depending upon your calculator and how your calculator types it in is going to depend on how you figure this one out. Okay? If when you type on your calculator and it does, so here on my calculator I would go log, and if your calculator opens up that parentheses right there, okay, then what you have to do is you have to close that parentheses before you hit the divide sign. Okay? Likewise, if you have the natural log and it opens a set of parentheses, you've got to close that parentheses before you do that. Okay? Another way around it is simply saying, just hit log, oops, I hit the wrong color, is simply saying, just hit log of 33, then hit equals, then hit divide, then punch in log of 3. Okay? It's all how you do your calculator. Okay? So try it on the calculator that you're going to use and stick with that calculator throughout this unit. If you're borrowing one from me, make sure you're always borrowing that same type. If you're using your own, make sure you're always using your own so you're not getting confused as to which kind it is. Now, on the Inspire calculators, when you type it, you can type it in right as is. It's kind of one of the neat things about the Inspire calculators. Okay? And it goes right there. Now, if I were doing this the other way, I would just go log of 33 divided by log of 3. Or I could go natural log of 33, of 33 divided by natural log of 3. And in either one of those, I get 3.813 is what I would call that there. we can now solve equations that look like this. I can give you an exponential equation. We can switch it over into logarithmic form, and we can find that variable. It goes back to earlier, well actually, we didn't have it this week, we had it last week, okay? When we had the 2 to the x power equals 10 question. And we graphed 2 to the x and we graphed 10 and we found those intersection points. Okay, and that gave us what it was. Okay? So we can take this equation and we can put it into logarithmic form. If I have 5 to the x equals 36, what is the logarithmic form of that equation? We should have that memorized by now. What is the logarithmic form of this exponential equation?
Log base of 36, sorry.
Log base 5 of 36 equals x. Okay? So I need to figure out what log base 5 of 36 is. Okay? Now, out using my brain, it should be, from yesterday, it should be bigger than but smaller than. Should be what? Smaller than 2 or bigger than 2? Should be bigger than 2 because log base 5 of 25 is 2. And it should be smaller than 3 because log base 5 of 125 is 3. And 36 is between 25 and 125. Should it be closer to 3 or should it be closer to 2? It should be closer to 2 because 36 is closer to 25 than it is to 125. Figure out what actually log base 5 of 36 is. I get 2.227. We will be rounding to 3 decimal points when we're solving these equations. Okay? And we round at the very end. In this case, the end of the problem was where we round. Okay? Right? You find me 3 to the x equals 112, what x is equal to. 15 to the x equals 4, what x is equal to. Now, logarithmic form of the second one is what? Log base 3 of 112 equals what x? Okay, all right. So then we said that that's going to be log of 112 divided by log of 3, or natural log of 112 divided by the natural log of 3, and that gives me what?
4.295.
X equals 4.295. Do we all agree with x equals 4.295? 295. This one. Okay. Logarithmic form of the third one here. Log base 15 of 4 equals x. So that's going to be either log of 4 over log of 15, or that's going to be the natural log of 4 divided by the natural log of 15. And that's going to give me an x value of 0.512. Does that make sense? That one is very close to 1/2. Why does that make sense that it's close to 1/2? You all shook your head, yes, that makes sense. Why does it make sense? Other than it's what the calculator told me it was. Okay. Why does it make sense? Why does it make sense that 15 to the x power equals 4 is roughly 1/2? Taylor?
Because the first, on the number line to get the integers, there's 0 and 1.
Okay.
Because log base 15 of 1 equals 0, and then log base 15 of 15 equals 1.
Is 1. Okay. And 4 is
In between.
kind of in between. Okay. That's one way why, but what's an even better way why, Kevin?
15 is equals to 16, which is the square of 4.
And so 16 to the 1/2 power is 4. Okay? 16 to the 1/2 power is 4. So 15 to the x power equals 4 had better be close to 1/2 because 15 is really close to 16. Okay? That would be my logic, even more so than Taylor's logic. Taylor's logic works too, okay? But that's the one that I was thinking of. Was that 15 is really tight to 16, and 16 to the 1/2 power is 4. So 15 to some power equals 4. It better be pretty tight to 1/2. Okay? Jumping back into your textbooks now, on page 820, okay, Mark and Scotty were each asked to determine which base was used to estimate the value of log base b of 58 equals 2.9. Mark said the log of 58 falls between 2 and 3 when the base is 4. So the base has to be 4. Scotty said the log of 58 falls between 2 and 3 when the base is 5. So the base has to be 5. My question for you and somebody near you is, who's right, who's wrong, with an explanation? Go. Who's right?
Mark is right.
Mark is right. Why is Mark right?
Because 58 is heck of a lot closer to 64 than 58 is to 25. So if it was, or 125. What did I say?
You said 25. Yeah.
Okay.
But I what to 125?
Yeah.
Okay.
If it was to 125, then it wouldn't be 2.9. It'd be like 2.4 or something.
This one. So this one you would think instead here, this one should be like 2.4-ish
Yeah.
based off of the estimation.
Yeah.
Okay? Alright? On the surface, Taylor, go ahead.
Well, I just said another way that me and Stephanie talked about it for Mark is because 58 is between 16 and 4, or 16 and 64, and since the base are both 4, that it would be closer to 64 than
So so we're agreeing that everybody thinks it's Mark? Okay? Now, on the surface, okay, was Scotty wrong? I mean, diving deeper into the pool that is this map, Scotty's estimate is probably a little off, okay? But on the surface, looking out over the water, is Scotty wrong? No. So they're both technically right. It's just Mark is a little more accurate than Scotty, right? Do you agree with that statement? Right? Technically, they're both right because their logic is true. Both of their logics are true. Okay? We could have also said that it was log base 6, right? Or 7. Could have we said log base 8? No, because log base 8 wouldn't be, it would be outside of the 3 range, right? Or it'd be actually lower, it should be less than 2 then. Okay? So technically, it's right, but Mark is just a little more accurate. Okay? Alright? So, what I would like you to do now is I would like you to answer those 3 questions. Okay? Determine the appropriate base for each logarithm. Be more accurate than Scotty. Okay? We like Mark, so let's be Marks. Spot check A. So 2.9, right? So that means I gotta be in between 3 and 2, right? Okay. So what's a logarithmic expression that's equal to 3 that's a little bit bigger than log base b of 108? Yeah? Log base 5 of 125. I would agree with that. Okay? Which means then my 2 over here would be log base 5 of 25. Does that work out for us? Having a b here of 5. Logically, does that make sense? 108 is a lot closer to 20 or 125. You're 25 instead of 125 right there. Okay, 108 is closer to 125 than it is to 25. 2.9 is closer to 3 than it is to 2, so I'm going to go with the base there of 5. Yeah? Okay? I'm going to skip to C first. Okay? What did we come up with for C? .1 is between 3 and 4. So what logs are we thinking about there? Log base. What are we thinking about for a b value in C? What are you, Kevin? 4. So if I go with a base here of 4, then this would be log base 4 of 64, because 64 is 4 cubed. And this would be log base 4 of 256, because that's 4 to the 4th power. Does that make sense? Is that logical? 74 is a lot closer to 64 than it is to 256, yes? So my base there should be 4. Let's go back to B then. What's that one got to be in between? -2 and -1. Okay. What are we thinking? What base are you thinking? 2? Okay. So if I'm trying a base of 2, okay, so that would be log base 2 of 1/2, right? And then this one would be log base 2 of 1/4. Is 0.4 in between 1/4 and 1/2? What's the decimal equivalent of 1/4? 0.25. What's the decimal equivalent of 1/2? 0.5. So is 0.4 between 0.25 and 0.5? Yeah? Are you okay with that one? Freddie, you're shaking your head no. What did you choose for a B? Didn't understand it? Okay. Well, let's try it a different way. Let's go with 3 then. You know what I mean? Okay. So if I went with a base of 3, then that would be log base 3 of 1/9, because that gets me my -2, and log base 3 of 1/3. 1/9 here is 0.11111. 1/3 is 0.33333. Is 0.4 between 0.1 repeating and 0.3 repeating? No. Okay. Let's try a base of 4. Log base 4, -2 would be 1/16. Log base 4 of -1 would be 1/4. So this would be 0.25. Do I need to even figure out what 1/16 is? No, because it's not going to be bigger. Okay. And my base has to be positive, right? So by process of elimination, B has to be 2. Okay. Later on in this chapter, we're going to go about a different way to solve for those B's. Okay? Make it nice and easier on us. Okay? We'll get to that later on. All right? Questions from today? Freddie, did I clear things up on that one? Okay? All right? Blue sheet is going to be your homework tonight. Since today is Wednesday, I think we can have this be due on Friday.